What's up, Mananap? Welcome to Code Conyo. So now we are down to the adding of at a certain position to our linked list. So we've already did add at first as well as add at last. This time we are going to do operations or operation which or that adds an element or data at a certain position to our linked list. So right here we are going to have here an explanation about our list through Java doc comments. So let's have here add add uh, add positions add at a certain position. So add element at a certain position to our or into the list into the okay. So let's have here parameter. So at parameter we will have parameter of the position. So it should be int, all right, and we'll have another parameter here which is the data. Okay, and say the data to be added. So for now, we are still working on um, integers. Okay. All right. So let's have here the a method. So let's say public void add at position. Okay. So and then have here int position. Have here int data. Okay. So as usual, we are going to test whether our node is empty. So if is empty. So sorry, is empty. We have then if a word is our list is empty, then therefore we need to call add at first. So okay, otherwise let's have here else otherwise we are going to do insertion at a certain position. So to do that, all we just need to do is we'll have to have here few declarations on declaration of or declarations of instantiation of our node. So let's have here visit and the link. So the visit is going to traverse the node while the link here is also going to traverse the node but at a certain in which what particular position we are going to actually stop from like inserting our node. Tama ba? Okay. Anyway, I'll just give you an explanation later on. So to do that, we'll continue with this one. So right here, we have to assign our like visit is equal to link as head. So both must be ahead. So so this would tell us that the visit and the link nodes are actually this time head. Okay, so we'll work on with the visit. So in the visit is we are going to have here a while loop in which it's going to visit all the nodes, and upon visiting each of the node we'll have to determine the how many uh, how many traversal are we going to do, or how many traversal are we going to, or how much traversal we are going to actually do in our entire list. So to do that we'll have to have a variable that actually increments its value, so we can name it like ctr. So let's initialize it to like 0, and then after that, while ctr is not equal to the position, so this would tell us, okay, So this loop would tell us how many traversal, or I mean, how, kumbaga sa Bisaya pa in layman's term, pila ka node atong i-visit. So up from the beginning, which is zero, until the position. Because again, we are going to uh, expect to insert our node into that particular position. So we should know in our list that our address should be like I mean the our node should be in that should get that particular address where our position is at that position. So by using our CTR or counter variable, so which is this time how to do that, we will just have to visit each node. So we have here that next, and then by just having a counter bus bus. So again, this would know how many reversal at up to what position only. So let's say we have um, our nodes has or our list has 10 elements, and then we are going to only like our position is we are only going to visit I mean to insert the our node at index 5. So therefore we are going to only visit up to that position, up to that position 5. Okay, because that's where we actually insert our data, and the rest is later on the rest will be just cascaded to the right side, now to the right side of our list. So know how many traversal process, okay, and then of course this is going to visit each node up to a certain position, okay, so meaning up to 5, okay, up to 0 1 2 3 4 0 1 0 1 2 3 4 and then 5, so meaning it will be inserted at the 0 1 2 3 4, and then up it will be inserted at the fifth position. Okay, so because fifth, okay, five or fifth. Okay, now this time this will, of course, this is a normal implementation, which is to stop our loop. Okay, so basically it will stop at when our CTR is at index 5. Okay, so right here, after that, we can now visit our node. So by visiting the while loop is going to visit the node, okay, and this would only uh, what we call this one, this would only make visit the node, those nodes that are already parang visited here, no? So sige, ako na lang i-ano ha, ikaw. So let's say for an instance we have here while let's have here link. So link that next, not equal to visit. Okay, so yan, the address of visit. So the last address of visit will be, it will be evaluated either the link rather that is the link of the address of this link that is visited next node to it is not equal to visit, then therefore our it's going to start in there. Now, the visiting of node will start from there. Okay. So how are we going to do that? All we just need to do is simply uh, increment or assign our that particular link with an address, okay, this particular uh, until this particular node, so that what that's why we do it like this. It's because so that it will not keep on traversing all the nodes to the rest of the nodes until the list, until the end of the list. So it has to make sure that the node that is visited is up to only of that level, up to that position only. So kasi we cannot afford of like visiting all the nodes, the entire nodes in that particular list. It would be, in terms of time complexity issues, of course, it is a little bit like efficient, and it's like it's not necessary anymore. All we just need to know is a certain position. Once we know that this is the only this is this certain position that we'll need to visit, then therefore that's the only way our node has to visit, or at least we have now an idea that's where we are actually going to insert our node. Okay, so right after that you can now assign, or you can now create a node. Let's say new node. Okay, oops, what happened? New node equals to new L node, right? And then after that we can now do the same as usual, like assigning the data to that data. And then after that, we should get the position of the address of that node to where we actually uh, link or insert the data for that node with that particular data. Okay? So, little bit, ano no, medyo confusing, pero anyway, I will be giving you a demonstration later on, like represent on how parang it would be easier for you to understand if we do it in a parang how the data or elements are actually moved or using the later on. So I'm going to show you. So we have here, you know that next is equal to the visit. So meaning whatever is the address of that node that is visited, is it will be assigned that node to that node not the address of that node. Okay. Now after that, we are going to, okay, get the uh, make that node as our new node. So meaning to say, this ones now will become new node that is inserted to that certain position, which we actually get to visit right here in this node. And those nodes that are after that node, after that node in that particular position, will just cascade going to the right. Okay. So what I'm trying to say is that, let's say for an instance, if you have, let's say, let's have 3 here, and then 5, 8, 9. So these are like your nodes. And then, of course, each of this node has addresses. So you have here the head, and this points to null. So if we are going to like insert 7 node at, uh, at certain position, like for an instance, we are going to insert this one at 2. So this will be inserted at right here. Okay. So you need to say this would create 3, 5. So since this one is 0, 1, 2, so therefore the list now would be, or this node now, which is 5, sorry, 7, will be inserted right here in between 5 and 8. This time it would create 3, 5, 7, 8, 9. And that's what this, and that's what this one, and that's what this loop all about. It has to visit first, way up to which particular node it is going to stop. So visit is equal to visit that next based on the position, let's say 2. And then now that we know that we are going to insert the nodes there at that position, then therefore we'll have to get the address of the nodes so that we're able to link the link the address of this node that is going to be like this node points to this node. So it is something like this one. So we'll need to do this, and this one should points to the node 8, making it like there's a link between 5 and to 7 and 7 to 8. And that's what we do at sorry, what we do at this part. Okay, so like we created the node, and then we insert it at a certain position, and then link this node to the nodes in between 5 and 8, and then cascade 8 and 9 afterward. Okay, so let's try if we are actually able to store the data or element at first or at last. So let's say for an instance, we have here ll dot add at position. So let's say we are going to, the position is, let's say 2, and then 3, 5, 7, 12, 15. So uh, yeah, we have to insert, let's say 50. Okay, so we're going to insert 50 at this list, or in this list, and then let's traverse here. Move muna this one, and then let's go run the program. So right here, so we are actually able to insert data or element 50 in between 5 and 7. So making it like 7, 12 to 15 are nodes in that particular list that are actually cascaded going forward or going to the right. So yeah, that's it. So again, let's go back from here. This loop allows us to know, or this loops allows us to know whether up to what certain position are we going to visit, and then after that, once we get to visit the node, then we'll have to traverse each of up to this node only, or up to this, yeah, up to this node only, and then after that we get to insert that the new node in that position, and then link the node at the right part, so which are, let's say, 7, 12, 15, to that new node, and then the node which is, let's say, what we have we added, like 50 will be linked to the node before that, which is actually 5. Yeah, so right, so all you just need to do is um go back to this one. You can trace actually whatever happens inside of this loop. Now we can actually I upgrade this conditions by making more logic. Like for an instance, what if we are going to let's say add at position, let's say 0. So it should be like, it should be trapped that once it is the index is 0 or the position is 0, instead it will be added at first, like, yeah, no, it will be added at the beginning. Another one is, sige, let's have it resolved here. So you can actually do this by like else if, or you can have like or here, no, or let's have a separate na lang. So let's have here else if position is equal to 0, and then you call add at first. Simple as that, no? Okay, so, right? And then let's go to our test linked list, and then let's run our program. So this will be inserted at the beginning of the list. 50 is actually inserted at the beginning of the list. Now, what if, so since we have, let's run our program. So since we have 1, 2, 3, 4, 5, 6, and we have currently 6 nodes, okay? Then how about if you're going to insert the node at like 7 position? So meaning there's no node in that particular position. So if we're going to run our code, our program, this would give us null pointer exception because the there's nothing uh, to visit. I mean, visit is already a null, so therefore, no, there's nothing to actually there's nothing is visited. I mean, nasobra na siyang visit sa mga nodes. So, you'll have to do error trapping for that. And then, how would you do that is, you just have to add something like, mm, oh, so pwede, else if, sige, ano na lang, else, how do we do this? Yeah, we can actually do like, if a position less than 20, right? Or we have position, okay, uh, greater than, let's say, how much do we have right here? So 0, 1, 2, 3, 4, 5. So 5. So dapat 5, something like that. Since we don't have a method that does that, that returns current size for now. So later on, we are going to create that. So for now, let's have this one. Let's stick to this one. So position less than greater than 5. Then after that, we can display something, an error. This position is not valid. Something like that. So let's try. So we have here, okay, position is not valid there. So meaning it's not inserted. So let's say, let's have here 6. So will it display the same? Position is not valid. So how about 5? So 5 is, it will be inserted, right? So, but this time at the last position, okay? So because we have 1, 2, 3, 4, 5, and 0, 1, 2, 3, 4, 5, and this will be inserted at the last position. You can also do that, something like that. Or if you don't want to insert this 50 at a certain position, you can actually do like 5 or like 4 up to 4 only, like 0, 1, 2, 3, 4. If that's how you represent your your list, like starts with 1 instead of 0. Okay, so but that's how you actually do it. Now in our next tutorial, I'm going to create the current size to for us to like we don't so that we don't put here a static value of 5. Okay, so that it will be dynamically as to as it follows on how many elements do we have already in our list. Okay, so I guess that would be all for now, and see you on my next video. Thank you guys for watching this video. Have a great day. Bye bye.